Hi, everyone. How are you all doing today? Have you heard about OpenMind before? OK. So today, I'm here to demo our software stack, which is OM1. OM1 is a hardware-agnostic layer, which connects to different kinds of robots. So I'll quickly start with the intro. OK, so this is the agenda for today. I'll start with the introduction. Then I'll go towards the architecture quickly, and then how to get started with this, and then how you can contribute. Then we have a quick demo with the dog over here. And I'll quickly demo our cloud-ISAC SIM as well. So for introduction, we are building software that brings cognition to the robots. OM1 is open source, and it's modular and hardware agnostic at the same time, which acts as a orchestration layer that bridges any robot to the cognitive infrastructure, which is also provided as API infrastructure through OpenMind too. It brings social intelligence capabilities to the robots. You can run it on Mac, Ubuntu machines, and we currently support Unitree Go2, G1, 𝗦𝗽𝗲𝗀𝗀𝗀𝗀, Booster, then 𝗦𝗽𝗲𝗀𝗀𝗀𝗀, it's a small humanoid, and also the turtlebot. OK, this is the quick architecture overview for you. Each robot comes with a different stack for their sensors. They have different microphones, speakers. They have LiDARs. Then they have location, GPS, battery, and everything else. So we take all these inputs. Then we also take input from the user. So if the user wants of the robot to look around and say something or do certain other things, you can give us a user prompt. So for example, I ask a robot, can you move forward or something like that? And then there's a system prompt which tells a robot what kind of personality it has. And then you can also name the robot. For say, this robot is named Bytes, and it knows what its name is. Then all of these inputs, along with the system prompt, goes to the LLMs. And the LLMs think and take different actions based on that. So all these inputs are taken. The LLM does the thinking and performs certain actions. Now, actions could be either movements, or the robot will talk to you, or ideally, if it wants to tell what's a battery or something like that. And these are the full autonomy features which we have. So there's face detection and anonymization, SLAM map generation, autonomous navigation. Then there's obstacle avoidance. The robot will navigate by itself, and it will avoid any obstacles which comes on its way. And then we also support auto charging for Unitree Go2, which is not supported for other robots. But Unitree Go2, when it drops after a certain battery level, it goes and charges itself. And we have simulation support as well. And the robot also does person following. So I'll quickly demo that too. So for there's another thing. If OM1 is open source. So I've put our QR code here for our GitHub repository if you want to take a look. And we're open to contributions from people if you want to integrate your own robot. So for example, if you have another robot which we don't support yet, you can raise a PR and try to contribute here. Or you can add support for different kind of sensors as well. So I'll quickly start with a demo now. Hi, Bytes. Hey, Bytes. Hey, Bytes, how are you doing? Can you switch to conversation mode? Oh, come on. Hey, Bytes. Sorry? Meanwhile, I'll try to show you the cloud simulator as well. Along with that, if you see, there's a portal here. You can choose which robot you are connected to. One second. OK.
Because OM1 is hardware-agnostic, it acts as a universal cognitive layer. This means you can use same intelligent software across different types of robots, like me, a quadruped, or even a humanoid, or a drone. It really simplifies how we manage and coordinate multi-robot systems. Have you had a chance to test out that portal interface?
Hey, Bytes, can you switch to greeting mode? I think the Wi-Fi is a little. Can you try? Huh? The robot? Can you switch to greeting mode? I think the Wi-Fi is a little slow as well. Let me switch. I'll switch to the other Wi-Fi. A sec. Okay, so this is the cloud simulator. I'll switch the Wi-Fi on the dog and I'll demo that. Meanwhile, you can take a look here. So there's a simulator here. We have a simulator for Go2, 𝗦𝗽𝗲𝗀𝗀𝗀, and also Unitree Go2, which you can choose from the portal. Hi, Bytes. Let me restart it. Okay, while the robot restarts, I'll showcase how you can try out different configurations in the simulator, and also how to get started on your laptops. So first thing you do is you clone the repository, and once you clone the repository, you'll have to ideally install a bunch of dependencies. So if you go here and go to our repository here, once you clone it, you'll find certain steps to get started. And the very first step is to grab the API key from the portal. So you go to the portal, go to the dashboard, and create an API key. Once you do that, you can define the robot type and also give it a label.
Lovely Wednesday, and I hope you're having a wonderful day. How can I help you?
So ideally, this is the portal, and once you get the API key, you just grab that and declare it as an environment variable. And I've already cloned the repository here. So the step is to export. You just export OM API key equals to, and give your API key here. Since I've already exported it, I will try to run by default. There are certain configuration files. So you run it by uv run source run.py and its conversation. Okay. So if you see that error, you just need to do some troubleshooting. Wait. Okay. I'll also show you how the configuration file actually looks like. So it looks something like this. You need to define the version. Then you define the name of the agent. And then there's the API key. You can even do it here or put it as part of your environment variables or export it over there. And then if you see here, there's a prompt example and also system prompt base, which is like, it says you're a smart, curious, and friendly dog. If you want the robot to have personality of a robot or a monkey or a teacher or maybe a psychologist or whatever you want, or somebody who roasts everybody else, whoever it sees, you can just tell the robot to have that personality, and the robot will act in that certain way. So that's basic prompt engineering. And you can also give certain example or context. So for example, if you're going somewhere and you want the robot to have some information about certain things, you just feed it as the prompt. And you go to agent inputs. Inside the agent inputs, you have different kinds of inputs. Like if you have the speaker, the microphone, and the camera. So we have Google ASR as input. And then you have probably if you want the camera to be there as well. So you give VLM, Villa. That's what we support. And then there's Cortex LLM. So we support multiple. You can plug in whatever you want. You can have Gemini, OpenAI, and we support OpenRouter as well. So through OpenRouter, you can plug in Anthropics or any other LLMs you want. We also support Ollama. So it's up to you if you want to host your local models. So you can switch to Ollama plugin and then make the robot respond through that LLM. OK, so here, if you see, I think you can't hear from the laptop, but it's running over here. And if I say hi Bytes or something like or Spot or whatever it is, it would listen to what I'm saying and then respond accordingly.
I see it over there. It's making funny noises, isn't it?
So ideally, the robot tells this, so this is like a virtual agent which runs on your laptop. And what is running on the robot is on the Thor. We have everything Dockerized. So this was the Python version. We also have a Go version, and we are migrating everything to Go as the latency is pretty less as compared.
I'm listening closely to your computer.
OK. OK, so here, this is the Go version, and it is pretty more faster as compared to the Python version. And once you can just run it on your systems as well. And Go is also compatible with Windows, so you can try out on that system as well if you want. It creates a binary file, and you can just run it on Windows, Ubuntu machines, or if you have a Raspberry Pi or other supported hardwares as well. Then apart from that, if we go on to, I'll show you a quick demonstration with the. OK, so here is our simulator. I'll start. There's a file called CloudSim. And if we just start this and put in CloudSim, so ideally, you will go to Machine Teleops, and you can see simulation robot here. So once you click on this, come on. OK, so you'll see the stream, which the robot is able to see on the simulator. And ideally, when you have a actual robot, you can also see the stream in the other portal. So the other portal which I have here is, so you choose your robot. I think there's network latency here, so you're not able to see the streams here. But ideally, that's how you look at the stuff. So this is the simulator, and the robot is here. You can see it on the portal what the robot can actually see. And you can start the SLAM mode. So what happens now is the robot will start moving around the place autonomously and start generating a 3D SLAM map. And while it's generating the map, you can save certain locations as kitchen or living room or front door or something else. And the robot would ideally know which place is what. After the whole map is generated, you can make see, the robot is now navigating by itself over there. And ideally, it's trying to map the whole area, and the map is getting generated, which you can take a look at the portal. So that's how the map is generating now. And once the map is done, you can click here and save the map. And after saving the map, when the robot is moving around, you can just, there's an option which comes up, save location. And once you save it, and the SLAM map is done, you can do the navigation mode. You can switch the mode from here to nav mode, nav2 mode, or you can also verbally tell the robot to switch the mode. So ideally, when it is in navigation mode, you can tell the robot, hey, can you go to the kitchen for me? And the robot will ideally go and go to the kitchen and do certain things, whatever you prefer it to do. So that is one thing. And then apart from that, there's person following and the greeting mode. I'll try to switch the Wi-Fi again, if we can do it. And so ideally, in greeting mode, the robot would track a person and walk towards the person and greets the person, have a certain amount of conversation, like 3 to 5 conversations, and try to find another person and go there and greet the other person and have the conversation. Do you guys have any questions or suggestions, or like, what do you feel about this? So App Store is like, if you want to build, so it's like different conversation or different JSON files or the configs which we have. You can ideally go to the App Store and either deploy your own applications. And so ideally how it works is, if you have a robot connected through the API key, so whatever API key you configure on any robot or your machines, it identifies as a machine on the portal, and you can create an app and deploy it on the app, on the robot based on the API key. OK, I think the map generation is complete now. So we can go ahead and save the map. I'm just going to say map2. And let's stop the SLAM mode and start the navigation mode now. There's one more feature for telepresence. So you can ideally, so if, for example, if you have a robot at home and you're not at home, plus your parents who are old are home, and you want to see if everything's OK or not, and you can also quickly hop on a video call with them through this. So you just do this here, and it starts telepresence. OK, so the other person on the other side would be able to see. So for example, my parents are not responding, and I want to check if they're in the living room or the bedroom or wherever, but I'm not able to track them, or they're not picking calls. So I can make the robot navigate through the portal and go to the living room or the kitchen or wherever. And then if I want to see what's happening, I can hop onto a call there. And ideally, we can see what's going on the other side, and they can also see us and have a conversation and see like if they're doing OK or everything's fine or not, something of that sort. OK, so now it's in navigation mode. And ideally, you can, if you want to have the robot in particular position, and you want to tell the robot, OK, remember this place as kitchen, you just put in here and save this location. And this location is now saved as kitchen. It saves the coordinates here. And that's how the robot would ideally know. And if now robot navigates to a different place, we can just tell the robot, hey, can you go to the kitchen? I can ideally ask it here. I'm not sure if you will be able to hear that, but hey, Bytes, can you move to the kitchen? So you can even save multiple locations here. And you can also make the robot move through these. There's a teleoperated, and you can make the robot go to different places through this, and it moves on the simulator there. And you can see the view. Then I can also show you other options we have for this. On the cloud simulator, you have different options. You can deploy whichever robot you feel like. You can try it with Tron, G1, or the Go2. And then you can choose different environments, either apartment or the warehouse. The current one is the warehouse setting. So ideally, it depends on if you want to deploy the robot in the apartment setting or warehouse. And then you can play around with that. I think that's pretty much for the demo for now. I'll try once again if I am able to switch the Wi-Fi there. But meanwhile, if you guys have any questions, I'm up for the questions. We have like a few minutes remaining.